Hi, welcome to this Open Security Summit session in March 2022. This is the first one, and we start with a bang. We're actually going to start with some of my favorite topics in the world, which is graphs and security. And we're going to see how these guys at JupyterOne have open sourced this React tool. And they're going to give us a nice tour of how everything works. So over to you.
Thank you so much. And yeah, thank you for having us here. We're really excited to be at Open Security Summit talking about Starbase. So yeah, let's get started. My name is Austin Kelleher. I'm an engineering manager here at JupyterOne. And I'm here with Adam Pearson, senior software engineer at JupyterOne. And we're really excited to be talking to you about an open source graph security analysis tool that we just released called Starbase. And we'll tell you more about it in the talk. So today's agenda, we're going to cover 4 different things. The first is graph-based security concepts. Second thing, we're going to introduce Starbase. Then we're going to go through like an actual setup and demo of the Starbase tool and showcase some genuine security analysis use cases with Starbase and Neo4j. Then we'll talk about what's coming up with Starbase as a project and how you can help. So graph-based security concepts. At JupyterOne, we believe that in order to secure anything, any system or service, there are 3 fundamental prerequisites. The first is knowledge of what you have, which maybe is familiar to people as like a traditional asset inventory, a view of all of your assets and properties of those assets. You can think of an asset inventory as like a table or many tables. The relationships are what give you contextual information about the assets. Relationships are what connects many tables together in meaningful ways. So that's knowledge of the relationships between what you have. And then finally, knowledge of what questions to ask about what you have. Once you have a graph that represents all of your assets and the relationships between them, you must know what questions to ask about the data in order to unlock like the true value of the data. So a traditional asset inventory might have many different asset types. So some of them are like users, groups, databases, servers. This only represents like a small set. Like at large organizations, like you could be looking at hundreds, thousands, tens of thousands of different resource types, and tracking and deeply analyzing the relationships between those resources becomes very important. So not only like the different number of resource types like users, groups, databases, and servers, but the sheer number of resources for those different types could be like many millions, could be billions of different resources. And you're interested in the contextual information about how they're related for security purposes. So the number of relationships between assets can become extremely large. So I put together like a few different examples here. There's actually even more relationships that potentially these resources could have to each other in some systems. So the number of relationships between assets can become extremely large. When our model is very flexible and highly relational, generating a graph of our data becomes a meaningful mechanism for analysis. So for example, we need to understand like which users have the ability to directly access servers or databases. That might be it might be done by seeing which groups users are members of, and those groups have roles attached, which give them permissions to access specific databases or give them permission to access specific servers. In some cases, those users might have direct access to databases or direct access to servers. Servers might have access to databases. There's all sorts of different relations that that can be built. And again, like it's only a small sample, of course. So then knowledge of what questions to ask. In order to ask complex questions, we must model a system in a similar way to how humans think. Humans think in terms of type and classification of assets and the relationships between those assets. Their thoughts then manifest as complex and abstract questions. Some questions are simple to ask or seemingly simple, such as who is Austin, which users have MFA disabled. Other questions require a significant amount of contextual information to answer, such as which code repositories are accessible to outside collaborators, which servers allow access to port 2020 or 22 from the public internet. And you can see that, like, as you start to have more complicated questions, the complexity is actually in the relationships between the resources, not so much the resources themselves. So we're going to consider like a small domain language for modeling graphs. There's 4 key terms. In order to answer abstract questions, it's important that we define a graph model that, as closely as possible, unifies our understanding of common assets and their relationships. So let's first consider an entity. An entity is a vertex in a graph that represents a resource within digital infrastructure. A relationship is an edge between 2 entity nodes in a graph. A type is a specific type that an entity is as defined by the source. So for example, in GitHub, a type might be a GitHub underscore repo. In Bitbucket, perhaps a GitHub or a Bitbucket repo. In GitLab, a GitLab repo, etc. That's the specific type of the target source. A class is an abstract supertype that defines what the entity is within a general framework of IT and security operations. So a GitHub repo could be classified as a code repo. A Bitbucket repo could be classified as a code repo, etc. At the bottom, you can see a relationship model between different resource types and classes. So for example, a user assigned an access policy is an example of a relationship between 2 different classifications of resources, users and access policies. A user group has many users, another example of class. And those can be broken down into their types, the specific types. AWS IAM user assigned AWS IAM policy, or Google Workspace group has Google Workspace users. To maximize breadth of data exploration, we search by class of assets. So yeah, classes and types are different searching mechanisms depending on the type of breadth and depth that you're looking for. So structured schemas versus flexible schemas and how they're both important. There's value in supporting both structured schema and flexible schema in graph data modeling. Structured schemas allow you to answer unified questions across many different target service providers. So in this specific JSON schema that you see here, we're considering user, a classification of user, which is described as a user or account to access certain systems or services. And users may have different unified properties that make it easy to search across many different IT systems. So email, MFA enabled, active, first name, last name. I'm sure these are properties that most of you have seen different systems or services support. They're not necessarily all properties of every system, but some subset of these is unified across many different systems. So if we consider like a property like MFA enabled, the MFA enabled property may be named differently in every provider, but unifying the property to MFA enabled allows the abstract question to be answered: which users have MFA enabled? Flexible schemas allow for differences in systems. So in some cases, it can be very difficult or even unnatural to model resources in a unified way. So an ideal system should support structured schemas and flexibility to have different resource classifications, types, and properties. So the queries that you see here are Cypher, which is Neo4j's query language. I'm using Cypher as an example, but any graph query language here is relevant, such as Gremlin, Sparkle, or JupyterOne's query language, J1QL, would also be relevant. An asset inventory is something that most people are familiar with, which contains properties of digital assets, of course. We may collect many thousands or different classes and types of resources to answer questions. And some of these questions, again, might be simple to answer, such as who is Austin? Does Austin have MFA enabled? And so in this slide, like you'll see at the top, there's a Cypher query that's specifically looking for a Google user and specifically looking for GitHub user. but so that would be a specific type of query to target sources of types GitHub and Google Workspace. But if you're interested specifically in like a broader range of resources, such as a user classification, and you want to find out who is Austin, Austin might be hundreds of different users. And so we need to be able to search by an entire class and a given unified property, such as email. Again, like, does Austin have MFA enabled? It's a very similar question, searching by class of email or user with properties email and MFA enabled, both unified properties. So that's a really quick intro to graph data modeling. We wanted to give you an overview so we could sort of have a deeper chat and demo of Starbase, which helps address some of these specific graph modeling problems. But just wanted to pause real quick. And if there is anybody who has any questions, I'll pause for like 15 seconds and wait. But you're welcome to ask any questions now. Otherwise, we'll keep moving and allow questions later as well. Okay, so I'm going to switch it off to Adam, and Adam's going to introduce Starbase.
Sounds good, thanks. So Starbase is our latest open source offering from JupyterOne. With it, we're able to build out rich graph databases that allow us to answer some of these complex security questions that Austin was just mentioning. You can go and go to the next slide, Austin. So what can Starbase do exactly? Starbase leverages our existing open source integration projects to collect data from services and systems, build out entities and relationships using that data, and store it all in a local Neo4j graph database. This provides us with three key advantages, some of which Austin has begun to highlight in the talk so far. First off, it gives us both deep visibility into a wide array of external services and systems. Thousands of entities and relationships are available currently out of the box. Second, our uniform data model lets us quickly craft queries across multiple systems without having to go to the trouble of performing any additional data normalization steps. And finally, Starbase is easily extensible thanks to our available open source SDK. You can go on to the next one. So we have currently have over 70 open source integrations available for use in Starbase today. You can find a complete current up-to-date list along with links to the individual GitHub projects for those integrations on our Starbase within our Starbase README file. We've also added an additional frame just to show we have a very wide range of system types that we ingest from. But even this list it really only represents a few types and a few examples of each of those types that are currently available. So our existing integrations follow the previously mentioned uniform graph data model, ensuring shared entity and relationship classes. The slide here shows the auto-generated data model for the auto-generated description of the data model for our Sentry integration. You can see that each entity has both a distinct type, such as Sentry member, Sentry organization, Sentry project, as well as a shared entity class, such as user, account, and project. All existing JupyterOne integrations are set up for this type of self-documentation, and it will be auto-generated and kept up to date. So our team is currently is constantly adding new integrations, but we do want to make every effort to enable any user that's interested, any developer that's interested, to be able to develop their own integrations. And to that end, we've open sourced our SDK as well as have provided an integration template to help any developers that are interested to get started creating whatever integrations they like. So before we dive into the real meat of the discussion and walk through how Starbase is configured and used, we'll have just a quick overall architecture overview. So once configured, Starbase sets up and runs each integration that it's configured to run individually. For each of those integrations, the locally built and executed project will query the third-party system it's ingesting data from and use that data to build out entities and relationships. Initially, those entities and relationships are stored in a flat file structure on the local file system. Once the integration is done collecting data, Starbase then triggers a request to the JupyterOne SDK to perform a Neo4j upload of that data. The SDK then performs the necessary creation and execution of Cypher commands to complete the data upload to our Neo4j database. Starbase will perform each of these steps for every configured integration until all of them are complete. So the Starbase has been designed to promote both ease of configuration and execution. One central config.yaml is all that is needed to store and manage configurations for all the integrations that we'd like to execute, as well as connection information for uploading all of that data to Neo4j. The 4 listed commands at the bottom of this slide are all that are needed to run Starbase. The initial yarn command installs any needed dependencies. Next, the yarn neo4j start command launches a local instance of neo4j in a Docker container. We added this so that we wanted to eliminate the need for detailed knowledge on how to set up a local instance of neo4j, although you're always welcome to do so if you choose. The Starbase setup commands will then clone all desired integrations to a local directory, install their necessary dependencies, and verify they have the correct configuration data provided in that config YAML file. And then finally, Starbase run will be the command that will actually collect and upload all data for all configured integrations. As one additional quick plug, we have recently added the ability to run Starbase completely within a Docker container for those that don't have access to Yarn and Node locally. And you can find documentation for that recently added, those recently added additional commands in our Starbase README file. And with that, I will hand it back over to Austin and we can run through an example of using Starbase.
Cool, yeah, so I'm gonna kind of go through a step-by-step guide of getting Starbase set up and getting like an example GitHub integration set up. We'll ingest data from GitHub into Neo4j and then run a few sample security analysis queries to showcase some use cases. So the first thing that you can do is just go to github.com/JupyterOne/Starbase and clone the repo here. There's some instructions here if you want to read more in depth, but I'm going to go through some high level details on how to get it set up and installed. So I already have the repo cloned, so I'm not going to go ahead and do that. But the next thing that you can do is just open up a text editor of your choice. And there is a file at the root of the project called config.yaml.example. This just contains some example configuration just to get you started. But you'll copy config.yaml.example into config.yaml, which I have done here. And I'll walk through a few of the properties just to help wrap everybody's head around it. At the top level, there's an integrations array. This is the individual integrations that you'd like to configure with Starbase. The name property is just a display name for logging purposes. So in this case, we just call it graph GitHub. Instance ID is actually important. It's used to partition data inside the database, because it's possible that you might want to configure multiple GitHub integrations or multiple Google Cloud integrations, et cetera. And you don't want specific uniquely identified entities to be overridden. So integration instance IDs are used to partition data in that way. The directory is the directory in which the that Starbase will clone these graph projects into. And the Git remote URL is, well, it is what it sounds like. It's where Starbase goes out and actually clones the repo from and stores it into this specific directory. The reason why that is the way that it is because we have a lot of integrations. We have over 70, and we're going to be adding many, many, many more. And these integrations need to be able to progress at independent rates for their libraries. As Adam had mentioned, we have an SDK, and the SDK is constantly, moving. And we want these integrations to be able to move at different rates. So what we do is we let them move at different rates. We clone the repositories locally with a Starbase command, and then we install dependencies. Starbase goes ahead and installs the dependencies for each of those cloned repos. And then the config property is used to define what configuration is necessary in order for the integration to collect data with a third-party provider. So in this case, we'll require a GitHub App ID, a local key file that it'll use to authenticate with, and an installation ID. These bottom properties are to configure the storage mechanism. Right now, the only engine that's supported is Neo4j. It's possible that we'll support more in the future. These defaults will work if you're leveraging the Docker container that we supply. So if you want to run the locally supplied Docker container with Starbase, we have a small script called Neo4j start. So if you have Yarn already installed, Node and Yarn installed, you can run yarn neo4j :start, and it will go ahead and run this Docker container for you. But I already have it running, and so I'm not going to run it again because it will restart, and it will take a minute to restart. So I'm going to go ahead and skip that step. People that are joining, I'm just trying to add people. So next, we'll go through the GitHub app setup. So GitHub apps, you go to github.com/settings/apps, which I'll go ahead and I'll paste in here for people that are interested in following along in the Zoom chat. You can click New GitHub App. The GitHub app name is not important besides the fact that it's globally unique. So I'll just call this like Starbase Test 3, and I'll say Starbase for the description. Homepage is also not important. I'll just make it the homepage of Starbase. You can scroll down, uncheck the webhook active. We're not going to be considering that feature in this demo. And the next thing we need to do is grant this application read-only access to specific repository permissions and organization permissions. So I'll select read-only for actions. These are permissions that the Starbase program will leverage in order to read information from GitHub. So read-only for actions, read-only for environments, read-only for issues. Metadata read-only is already checked. Read-only for pull requests, and read-only for secrets. And I want to call this out. This doesn't give read-only to the actual secret contents. It only gives read-only information to the existence, the metadata about the secrets. So for example, if you wanted to ask a question such as, which of my repos have access to specific secrets, you would need to give Starbase permission to read this, but you don't have to give, most of these permissions are not required. Organization permissions. So for read-only for administrator metadata, read-only for members metadata, and again, read-only for organization secret metadata. Scroll down, you can skip over user permissions. And lastly, select any account. So where can this GitHub app be installed? Currently, like this GitHub integration doesn't support individual like user accounts to be installed into. That's something that we are going to add, but right now it's not supported. So if you select any account, we can install it into an organization. Create GitHub app. And so at this point, I am going to post a gist into the chat that will give some sample, give a sample configuration file that you can follow along with if you are. It should be right here. So I'll just open it. So yeah, this sample configuration right here, you can copy this into config.yaml at the root of the Starbase project. Like I said, I already have one that's mostly configured, and you'll replace GitHub app ID, the value of these three properties, which I'll walk through now. So app ID can be found here. Replace it, and installation ID, or actually scroll down now, and we'll need to generate a private key from this page. So I'll just go ahead and open this up. And scroll back up to the top, click Install App. You can select an organization that you'd like to install into, and click All Repositories. These are the permissions that we just configured for this new app. Click Install. And now we have this app installation, or the app installation ID in the URL, which we will also need. So we can copy that, paste it into the installation ID property. And then lastly, we just need to update the value of this to wherever on your computer that it was downloaded to. So in my case, it's in downloads. I'm just going to copy this file name and replace it. And now we have everything ready to actually just start running Starbase commands. So the next thing you'll just need to do is ensure that you've run yarn at the root of the project. That just installs relevant packages into the project. And I've already done so, so I'm gonna skip that step. And then run yarn Starbase setup. This is what actually goes out and clones the repos. And because we have GitHub configured here with the GitHub remote URL and a directory, it'll go out and clone the GitHub integration project. You'll notice that it got cloned into .starbase.integrations. Here it is right here. This is all the code for the GitHub project, which is also open source. I'll really quickly just bring that up. So you can go to Jupyter One. And if you search for graph hyphen, you can see most of our open source integrations like Google Cloud. Here's GitHub right here. So all of these integrations are all open source and independently runnable. So you don't have to run them with Starbase, but Starbase helps orchestrate this. And lastly, now that we have all the projects cloned locally, we can run yarn Starbase run, which will actually go out and leverage the credentials that we've supplied and trigger the integration to collect data from the third-party provider, in this case, GitHub. It might take like 15 or 20 seconds here to go and collect all of the relevant data. And then it goes and uploads the data to Neo4j. And now we're ready to start actually diving in. So if you are like using the local Docker setup that we've supplied, you can just open localhost 7474/browser. And if it's your first time, you'll be asked to input the username and password. The username and password is actually specified inside of the config file. So if you're just using the defaults, it'll be Neo4j and DevPass. So I'll just go ahead and type those in, Neo4j, DevPass. Okay. So now we're ready to start kind of actually diving into what data has been collected. And you can configure this with many different integrations, like every integration if you'd like to. We only have one configured here, but So here's some data that already exists in my database. As you can see, I've configured some other integrations previously, but I'll select the node label for GitHub_user and start looking at this. So here's 3 GitHub users that were ingested from our org: Austin, Adam, and some test user. You can begin to start like expanding outward of these nodes and exploring like what types of data has actually been collected and how it relates to other data. So here's one user called Austin Test who manages the entire organization, this GitHub organization. This GitHub organization owns this GitHub repo and this GitHub repo. And both of these GitHub repos allow Adam Pearson to access the repo. You can even start looking at properties on the relationships and digging in to see what roles does this specific user have access to in terms of the repo. And so we previously had talked about searching by class and type, classifications of resources and types of resources. So in this case, we were searching by type, but we can even take it a little bit further and search by class. So I'll say like match u, this alias, user, return u, and we can get every user across all the integrations that I've run. You can see there's other ones in here, such as the Google Workspace integration I had previously run, and some GitHub users, and many different user types. I can even take this even further and say, one of the other questions that we raised earlier is which of my users across all my IT systems have MFA disabled? And when each of the integrations are following the unified data model, we can run a single query like find user with MFA enabled as false. I'll run this again. Here are each of the users across IT systems that don't have MFA enabled. Some Google Workspace users. There is a user like from Sentry, Sentry.io, if anybody of you have seen that system before. These are users who don't have MFA enabled. You can go to the table view and see more information in here. Now let's start like diving a little bit deeper into a slightly more advanced use case that requires relational data, relationships across nodes. So for example, which GitHub users have access to GitHub repos as outside collaborators? That's important because at any given time, someone may have added a user as an outside collaborator to a given repo. Perhaps it was important at the time. Maybe it was an accident. Maybe this person doesn't need access anymore, and you're just trying to audit that. So here's one query that I prepared. Find me all of my GitHub accounts that own GitHub repos that allow GitHub users where their role of the user is outside. This is a property that's exposed by GitHub. So there's one user in our GitHub organization, GitHub account that owns this GitHub repo that allows this outside collaborator. You can see that the role of this outside collaborator is outside. They're an outside collaborator. And you might want to take it one step further and say, okay, well, maybe I'm only interested in outside collaborators that have administrator privileges. In this case, a repo might have multiple relationships to one single node. It could all direct to the same node, one node to another node, but they have many relationships, even relationships of the same class, like allows. And so in those cases, we actually place properties on relationships. So we will run one more query, which is very similar, but in this case, we'll consider only outside collaborators where their role is admin. You can see it on the relationship here on the right. And it will actually return the exact same data, so it will be no surprise. But that would answer the question, which of my GitHub users have access to GitHub repos as outside collaborators with administrator privileges. One last example that we'll run through is with networking resources, which I'm sure many of you are interested in networking and access of specific machines. So we'll run through a demo of like some data that we've already prepared related to Google Cloud, which Google Compute instances allow access to port 22 from the public internet. And I've prepared this query here. This is actually, by the way, straight out of the CIS benchmark, Google Cloud CIS benchmark. So if you're familiar with the CIS benchmark, perhaps you're familiar with this specific question. So in this case, I won't go through every single detail here, but we're interested in instances, their networks, their subnets, and the firewalls that protect them. Firewalls have properties of ingress and egress, and we're interested in only one direction, as well as a very specific port range, in this case, 2022, and with TCP protocol. And I'll run this. So in this case, there's one subnet. So this is the full relationship tree that we were just considering here. But in this case, there's actually 2 Google Compute instances in our Sandbox account that are allowed, that are accessible via port 22 from the public internet. And they're probably instances that we should look at and address specific issues with. So that's it for the demo. Just to kind of recap, what we did is we set up Starbase, we set up a sample GitHub integration, and went through and ran Starbase, and went through specific security analysis use cases for why graphs make sense to answer questions like these in an abstract way. So I'm going to switch back to the presentation now. Hold on. Cool. Okay. So what next? We kind of went through like a real world demo, and we're going to talk about like a little bit of roadmap items very quickly. So the first is Starbase policies, which we're really excited about. Starbase policies are essentially going to be a series of canned queries that you can run, some of which I just showed you. We'll source them from many different sources, some of which we've come up with on our own, some of which come from like compliance standards or other security frameworks, and allow an automated way to run those queries on a scheduled basis, or triggering them whenever you'd like. Helm chart. So this would be a mechanism to deploy Starbase into some environment like Kubernetes. Many new integrations. We're constantly adding new integrations to different platforms. And if you're interested in building integrations, we'd be happy to talk to you and show you more in detail. We have documentation, but we'd be happy to even work with you on building new integrations if you're interested. And improved automatic documentation. We integrate with so many services today, and we need better visibility into what specific data is ingested in a more consumable way, as well as like potentially properties for each of the different entity types. How can I help? Well, if you enjoyed the talk today, like really would appreciate like if you would consider starring the repo. Like it's really small and it helps us out a lot. We're super interested in this project, and we're going to have tons of new things coming soon. Open issues for bug reports and requests. If you have any interest in that, PRs are super welcome. We're even happy to like help you work on PRs. If you have some ideas of things that you want to see done, like we can help you work on those. And lastly, there's a Starbase Slack, and the link to the Slack is actually in the GitHub repo. So if you're interested in joining the Slack channel and having more real-time communication, we can you can explore that as well.
There's a question here for you from Christoph. Hey, Christoph, who actually, is somebody that I mentioned in the past I should be looking at putting a graph database to his app. It says, is there an integration to ingest CSV files?
So that's a really great question. We don't have a So we don't have a Starbase integration to do that. And it's something we could absolutely explore doing. I don't think it would be a very difficult integration to build.
Yeah. Now the existing Neo4j ability to do like a load CSV and have Neo4j load CSV data manually, that obviously would still be available, but we don't have any custom integrations for it yet.
Mm-hmm. Yeah, good call out.
Right, thank you. If you want to ask more questions, you can just go.
Yeah.
I have actually a couple of follow-up questions. So what I'm currently doing is, because as an organization, we have a tool where we manage our identities, so our employees, and I'm gathering data from different systems to see where employees have an account. So actually what you've built is kind of what I like to see. For example, I imagine it would be possible to display all the applications that have accounts that cannot be mapped to an identity or to an employee of an organization. Have you done anything like that, or maybe an example?
Yeah, good question. I think so. There's a couple different things I think that are worth calling out there. One I think is like specifically ingestion that's like specific to those providers, such as applications, which some of the integrations do ingest applications from platforms. So like Okta, I think, is an example of an integration that we have that ingests applications. But you're specifically interested in mapping data from like cross-provider relationships, right?
Yeah, exactly. So I mean, we have lots of SaaS applications in use, but we also have some on-premise systems. So I'm not only talking about applications, but also maybe systems where employees have access to databases they have access to. So everyone, whereas we follow an account, so a naming convention. So it would be easy to map all those information. Mm-hmm. Currently, I have the information in a MySQL database, and I can map, like I can see what employee has what applications or what permissions, but it's all in a table format. So it's not very, if I want to spot employees that have unmapped accounts, I can write a query for it and get a list, but it would be great to kind of see the relationship between the users and the application. And if I click on the relationship, like the arrow you did before, you see, well, what role do they have in this application? So I imagine that it's a lot more powerful when doing it in a graph database rather than in a relational database. So that's kind of what I would be interested in to use this solution to kind of get that visualization of the data.
Yeah, I think that what you're describing is like a perfectly ideal use case for a graph database, a really flexible model, and there's so many different sources of data, but they sort of are classified in specific ways, such as users and applications, and which users have access to those. It sounds like perfectly ideal for a graph database, and so I mean, depending on how you would want to get the data into Neo4j, like Starbase could be a good, like using our SDK could be a great way to do so. Or as Adam Pearson had said, like there's capabilities with CSV uploads. So yeah, I think that what you're describing is a great use case. And I guess I'll also call out that some of the integrations that JupyterOne does support have like support cross-provider relationships, which we didn't really talk about in this talk. I think it's more of an advanced topic, but like as an example, some of the more interesting relationships stem from when you can't source them from one provider. You might ask a question like, which of my Okta users have access to AWS resources? That is actually a fairly complicated question because it requires you to have information about your Okta users or groups and which AWS IAM roles they're assigned through some mechanism. And then information from AWS about policies and et cetera, all the way down the resource chain until you get to resources. And so that cross-provider relationship is also like extremely interesting. So I think that's also just worth kind of calling out.
Thank you.
Throwing some ideas for you guys there. One of the things I feel we always need with this is to kind of create a community of individuals that know how to use this and know how to drive the value from this in an organization. Because I think the problem you have is you can go to a security team that is already maxed out and you go, hey, here's a great set of toolkit that you can do all this stuff. But I actually find that a lot of companies and a lot of security teams, they don't understand graphs natively. Yeah. They don't, they default to spreadsheets, they default to these things, or they buy, products and services that have a graph, but provide you almost like a photograph, a kind of a slice of it, where I think what you need is really ways to start integrating those questions, that ability to ask those questions natively and find ways that, how do you accelerate the adoption of this in organizations? And some of it is services, some of it is teams, some of it is individuals, some of it is kind of like that documentation and that process to say, how do you tackle this use case? How do you tackle that use case? And I think that's very important.
Yeah, that's really great feedback. And I think that's actually one of the interesting things about like graph security as a full domain is that like it's been around for a little while, but still organizations aren't fully like adopted into that. In fact, it's like so new to people as a whole, I think. And I think like one of our goals is actually to sort of evangelize the idea of graph-based security analysis. That's like one of our ultimate goals, is to really like, how can we get the industry to move in the direction to believe that like this is something that provides significantly more context than flat views.
But the key, right, is to evolve graphs into maps. So the session we're having this afternoon, see, the big epiphany for me was when I realized that the key piece of the puzzle with graphs was maps. Because especially if you look at worldly maps, and that's one of the things, and the beauty of the summit, we got this intersection of ideas, right? Mm-hmm. Worldly maps is a great example of how you can think and you put context. I think a lot of times the problem with the graph, it takes you like 80% there or 90% there, but the final bit, actually where you start to have context, is actually you need a map. You need to put things into context. You need to make sure that you can look at information and really connect the dots and really know how to get out of it, or actually create graphs of graphs of graphs, where you start to correlate the information, and then you basically start to almost generate value at each layer, allowing decisions to be made at the end. And that question you mentioned, that use case is the critical one. Like, I got my Okta users, and who has access to that, and who's impacted here, or who's connected to where, and what, the whole zero trust again, or I say incremental trust that you have. You need to start capturing that information in a sort of graph-like format, so that you can then extract and create a lot of better knowledge out of it. And that's what a map gives you, which for me is quite exciting.
Yeah, I'll definitely have to join that session later. Thanks for plugging it. I'm excited about that.
Yeah. Sweet. All right. This was really good. Oh, what a great way to start a summit. Love it.
Do we still have 2 minutes for more questions?
Exactly. If any final questions from the participants, just put on a chat, and then we can always bring you guys in. If not,
so if no one has any questions, I have a couple more.
Yeah, no, go for it.
I think an interesting, I don't know if you support that, would be to ingest PCAP files to visualize network traffics, or which machines talk to which machine. This is something I wanted to look into, and I thought Neo4j would be good for that. My skills are very limited in that area, so I had problems ingesting the data. So that it's probably not relevant for this project, but maybe you've come across something similar. And the other question would be getting data from Elasticsearch into this tool to do mapping. Is there an integration for it, or is there anything planned?
Yeah, that's a great question. So I haven't personally, I'm familiar with PCAP files, but we haven't personally looked at building an integration to ingest data from them and relate them to different resources like hosts. That's something that's definitely worth exploring. So I appreciate the idea there. As far as like your second question, getting data from Elasticsearch, I mean, it certainly sounds like it's possible. Again, something that I personally haven't explored. Adam, I don't know if you know anything about that, but my guess is that there is the ability to integrate Neo4j and Elasticsearch in some meaningful way. Or the alternative would be, again, you could write like a Starbase integration using our SDK, just leverage the Elasticsearch Node.js SDK to fetch resources from Elasticsearch and upload them in the ways that you'd like. That would be definitely supported.
All right, thank you.
Yeah, thanks for the ideas. I took note of those. Where can we capture these use cases? James wants to know. So, I mean, I'm definitely taking notes. So there's a few different things. One, I think I called this out in the previous slide. One is like, if you really do like have ideas, like some of these are really great ideas, feel free to open up issues in GitHub as feature requests, or we can have discussions in GitHub. That's totally awesome. Love to do that. Alternatively, if you're interested in having more real-time communication, like feel free to join the Starbase Slack. I probably should have just like dropped it in the chat here. It's in the GitHub repo. I don't have the link prepared, but it's in the GitHub repo, and you should be able to find it there. You can join and we can have some conversations as well. So let me see this. Here's the link. If you're
so just a quick one on that Elastic.
Mm-hmm.
I highly recommend you take a look at it. In fact, I use Jira as a graph database, which I always find it's an interesting concept, but I don't actually use Jira as a graph. I use Elastic. So what I do is I synchronize Jira with Elastic in quasi real time. Then I query Elastic for the data, the issues. Basically, I use Jira as the node repository, which is actually a very effective way of using it because it solves lots of problems of data consistency, data integrity, features of the node, makes the node very rich. So I tend to use that a lot. But then Jira sucks for querying, is highly inefficient and is not the best one. So what I then do is I pump that data into Elastic, and Elastic, until you hit millions, right? It works really, really well and it's super fast. So it's almost like, I think, again, Elastic is not a bad repository. And I actually think an interesting thing is to actually go from, for example, a source or JSON into Elastic or Neo4j, or that Neo4j Elastic. It's kind of like, I think there's a combination where you can use multiple players. And there's also a lot of people already, a lot of solutions that know how to natively send stuff to Elastic. But Elastic it's already a graph when you look at it, because especially if you think about it, the histogram, right? There's already a connection there. There's already things you can hook. And Elastic tried to create a graph out of it, but it's not very good. Well, last time I used it. So I think there's lots of great synergies that you can have there.
Yeah, that's a really great point. Thanks for sharing that.
Yep.
I think that there was one question that we missed. Michael had asked, do you have any use cases with event data? So mapping permissions to permission usage and leveraging it to minimize scope. So I guess like what I'd say is right now, like in Starbase, we don't have event-driven ingestion support easily. So like as an example, CloudTrail event processing is not supported natively in Starbase. But it's something that has been brought up like quite a bit. We consider it like internally a lot, like with our platform. But yeah, it's something that we definitely would like to consider for specific services. I think GitHub, it's also a really great use case. GitHub Cloud Service Providers. It depends on the type of data that you're trying to ingest. what use cases actually make sense. Cool. Any other questions? Well, thanks everyone so much for having us. Open Security Summit. Everyone who's involved with that, I really appreciate that. And oops, I didn't mean to click this. Yeah, and thank you guys for having us. It was really fun.
Yeah, good stuff. And let's do another session in 2 months from now.
Okay, sounds good. Bye.